notice that again, in like our function that reads a string of any length, it's very, very broken down into a lot of subproblems, right? We basically say, read the first non-white space character, right? And while the character that we haven't read is a space, add it to the end of our string, then get the next character, right? Which if you look at what we did up on the chalkboard earlier for reading your lines, how much different is it from what was on the board before? You should see about like 2 changes, right? Like we had something like, instead of using like fscanf to read a character, right, we said we called our function read line to read us a line. So those 2 lines were different, and then pushback was the same, right? Because adding an element to the end of the array is something that's 100% identical, except for the type. The types change, but everything else is the same. Yeah?
So doesn't this function hold?
The first one will ignore the leading white space.
Yeah.
Then this one will keep reading characters until it finds the first white space character, and then it stops. We want to read the, yeah, we stop at the first white space character. This will cause us to stop here.
Not have hardware.
So like this guy is what's preventing, this is what causes us to stop at the first space. If you change this, you can make it stop at something else.
Okay.
Right, but now we can go ahead and we can try out these functions that we wrote, right? So we might have something like pound include, what do we call it, string.h. And then we might say something like printf, enter a string, right? And then we have our std string, s is equal, oops. So then we have like our std string, s is equal to, what do we call this function back here? String read any length. And then we want to read from standard in. That's from the keyboard. So that's the file pointer that you would use if you said you wanted to specify the keyboard. So printf, right, always prints to, I could write this as like fprintf to std out as my file pointer that I wanted to. And so printf is just a nice convenience function so that you didn't have to write std out every single time to specify what file you wanted to write to. But again, read the code that I gave you and the slides that I gave you in class last week for about opening and reading from files. It's very simple. So now we might do something like printf sent us you entered sent us s dot contents after I throw in a comma here. And now I can, if I didn't, oops, we forgot to do something. I forgot to delete the string that I allocated. But here I can be, as long as I, oops, no spaces, as long as I want to, and get it back. But I need to make sure that I do like string, so destroy string, delete string, and then pass in the address of s, so that I release my dynamically allocated memory. So for question 10 on the determinant problem, if you're getting a memory leak, or not memory leak, if you're getting a seg fault only for that one, test case 10, it's not actually a segmentation fault. It's just that you have a memory leak in that problem, and I actually checked for it there. The way that you can figure out what your memory leak is when you go to the assignments, what you should be able to find, and I'll look at this in my submissions. So final project, C programming. which I guess I need to submit that one so that you can, oh wait, no, I did submit find determinant. Oops, come on. So if you go into the history of find determinant, which you can find under your grades, and then you click on submission, you'll find this file right here. And this file will tell you what's wrong with your program. It will tell you like where the memory leaks are at, or at least how many are occurring. And so you need to get rid of all of them. Mine doesn't have any memory leaks in it, but a lot of your guys' did. So make sure that you release the memory when you're done with it. And the number of frees should be equal to the number of allocations, right? Like mallocs, callocs, reallocs. Not necessarily reallocs, but the amount of time that you create new space and create new pointers to that space should be equal to the number of frees, so that you free all the space that you create. Would you guys like to see us do anything else with our string besides like print it out? So like what we could do is say something like enter your first and last name. And so what we could do is have this be something like first, and then we can have another string second equal to string read any length from standard in. I guess, you know, first, last, and might say like you are %s space %s, and then we could do first dot contents second or last dot contents. And then we need to make sure that we delete both of them. So delete first, delete string, second, last. And so now when we run this, right, I should be able to do something like space, 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 Matthew, space, 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 Butner. And it works. It might not seem too impressive, but we're able to get a string of any arbitrary length and not allocate more space or less space, right? So even if the user has something like, oops, here, you have like super duper long first name, amazing, can't even pronounce last name, right? Something like this, like their names are really long. It works, right? So we're able to be really, really flexible. Yeah. No. Because again, this guy here wants a string and is first a string, like a C string, a chart pointer.
No, but I'm saying in the structure.
Well, you could have a function that's like print string, and then you have to say like print string first. But no, not a nice way of making this happen. That's why like being able to overload the outstream operator is really nice in C++ because it makes printing really easy. Do you guys have any questions about any of the work that we did with the string and the dynamic memory allocation? Okay, so there's one other topic that I want to talk about in string with C. So in C, there are no templates, but there are macros. Macros also exist in C++ and have the exact same syntax. What macros do is they allow for direct substitution. So you can do some really complicated, really, really crazy things, but they're also really, really painful to debug, and you can have really weird problems when using them. And so implementing them correctly is a really tough challenge. So like with templates, right, the compiler basically allows you to do text substitution, but only with the type. The macro allows you to do text substitution anywhere, and it can be as arbitrarily complex as you want. So macros tend to be put into two different types, even though they're the same thing. The first are variable-like macros, where you say #define, the name of your macro, and then value. And now whenever you put the name of the macro, the compiler is going to replace it instead with the value on the right-hand side. When it's really common to see macros written in all caps, again, they can be arbitrarily complex. So here I have #define pi as 3.14159, #define name as Matthew. So here I said, printf pi is %lf pi, my name is Matthew. So what's going to be different from this and like a function call is the macro will literally copy and paste in the text here. So when it sees pi, it literally rewrites 3.14159 there. When it sees name, it's really going to place it with quotation mark MATTHEW end quotation mark. Whereas with a function, right, it's going to replace it with the value. And so it'll go look in memory at that address for the value that it found there. So it's very different, even though it might look the same. This also might get a little bit more confusion with the function-like macros, because your macros can accept arguments. But when you pass the value in for the arguments, again, the text gets copied and pasted directly in there. It's substituted directly. When you write one of these types of macros, either one, the contents of that macro has to be on one logical line of text. So you might have some really nasty looking things where it was like super duper long and hard to read. But you can continue one logical line across multiple physical lines by putting a backslash at the end of it. And when you want to use the macro, use it just like a function. So over here we have a function that does max. So it does max AB, A greater than B, question mark, A, otherwise B, right? Just finds the max. But again, instead of like doing the function call, everywhere I write max, it literally will paste in this section of code here on the right-hand side, with the A being replaced with the first argument and the B being replaced with the second thing. I can have it be more complicated, like print n to m. And again, anywhere that I do this, it's not going to be a function call. It's literally going to copy and paste in this section of code here, but with n and m replaced with whatever the values are there. Does that make sense? So again, like there's no typing here, right? It's just copy and paste this code somewhere else. So here, like when I do print n to m, it's literally going to like copy and paste this for loop and then replace the n's with 10s and the m's with 20s. Or if I do this max right here, it's going to copy and paste this code, parentheses 35.26 greater than parentheses 33.79 question mark parenthesis 35.26 parenthesis colon parenthesis 33.79 parenthesis. It literally copies and pastes that in. So here, notice that this max function works for both doubles as well as working for integers as well, because there's no types. It literally just copies and pastes that text there. Does this make sense? So here's some fun problems you can have with macros. So because the arguments to a function are, again, directly copied and pasted in and not evaluated like they would be to for a function, and then the result value would be passed in, you have to worry about order of operations. So to prevent problems with order of operations, you need to use parentheses. For example, over here, here's a bad molt function. AB, A times B. Does that look terrible? Right? Anything wrong you can spot with that line? No, it looks fine, right? But now let's say we call bad molt with 3 plus 5, comma 4. Well, now A is 3 plus 5. So you get 3 plus 5 times B, the 4, which is going to now do the 5 times the 4 and then add it with the 3. Is that what you wanted? No, but if you had if this was a function call, what would happen first is we would do the 3 plus 5. That would be evaluated into 8. Then the 4 would be evaluated as 4, and those values would be passed to the function. That's how macros and functions different. It's literally copy-paste. But the good molt, notice it has parentheses around A and B. So now we have, 3 plus 5, 4, but it is 3 plus 5 in parentheses times 4 to give us the answer that we actually desired. Any questions here? Yeah. If B were a pointer, would it try to dereference it? No, it would attempt to do the multiplication. Because again, the star was in between two values, so that means it means number times number. If the star just appears in front of a variable in terms of the parsing of the C code, then it will just dereference the pointer. Any other questions? Yeah. Like a number times number. It's literally going to put it in there. Right? So if this was 4 times 5 plus 9, it would literally substitute into A 4 plus 5 times 9. And that's what gets written there. So again, just copy and paste your argument into that spot. That's what you're going to get. The other thing to watch out for are side effects. So sometimes your arguments can have side effects, and so it's really important that you evaluate your arguments only a single time. In this example on the right, with the bad max, right, even though we try to account for order of operations by having the parentheses, if A is a method that has a side effect, it's going to cause some weird behavior. So let's say we had plus plus A plus plus B, right? Now everywhere you see A, you replace it with plus plus A. So you get plus plus A greater than plus plus B, question mark, plus plus A. Otherwise, plus plus B, right? Notice this plus plus happens potentially twice. So if I have 10 and 6, well, first we'll do the plus plus and get 11. This guy gets plus plus and gets to be 7. So we have 11 greater than 7. Well, 11 is greater than 7, so we'll evaluate this guy, plus plus A. So A gets incremented again, and now A became 12 as opposed to returning the 11 that you were intending. Does that make sense? This side effects don't only happen with just plus plus. If someone had done like a plus equals in there, you'd have the same issue. Or if they had called it with a function, again, and that function has side effects, that function now gets called twice in the spot. So you have to be really, really careful with this. Over here, you've probably seen something really weird with the good max, where the result is enclosed in parenthesized curly brackets. This is a GCC extension. It's apparently not like standard C. But what will happen is the result of this expression will be the result of the last line evaluated inside of it. So what happens over here is I pass in my type, so I know what the type of A and B are. And so I'd pass in something like int A, B, and then we'd get, int would appear here for the type, so we'd have int underscore A equals A, underscore B equals B. So notice they're only evaluated a single time. And then we'd compare the underscores with each other, which have already been evaluated. And so we'd actually do the correct thing and get 11 back here in this case, as opposed to the 12. Any questions here? Yeah. Yes, it's kind of like convention to write it as like underscore A. The problem though that you would have here is if the person named their variable underscore A, then you'd have like underscore A equals underscore A, and it gets a little bit confusing because this guy would begin to shadow the underscore A that was passed in. So you'd actually initialize yourself to be whatever your uninitialized value was, and then things start to break. Oh no, type was just a parameter in here.
Okay.
So I have an example of this guy. Over here. So over here I have that good max guy, same as it was on the slides. Like, ignore this vector stuff for right now. We'll get to that in a minute. So here you have 10 and 5. And so if we do plus plus A plus plus B, what do you expect to get back? 11. And notice this guy right here, this type was just the keyword int. So now here where you see type, you replace type with int. So int underscore A, right? And if we run it, you're going to be looking at the bottom two numbers. We should see 11 and 11 show up. Oh, aha, 11 and 11. Now, like the examples that you've seen so far are pretty bad examples of using macros, right? You really want to prefer to be using functions wherever possible because the functions have that type safety. They're going to behave like you expect. You're not going to have to deal with all the weird side effects or order of operation things. So prefer to use functions. They do allow you to do some really complicated things like Google Test has quite a few macros in it. So it's being used there to make like the test cases. But here, what I decided to do is I tried to implement a templated vector class in C, but I used macros instead. So hold on to your horses because it's about to get crazy. Okay, so over here, the two methods that you would want to use would be vector declare to get the declarations of your vectors, and then vector define to get the definitions of your vectors. And so the vector declare goes into the header file, so I'm declaring an integer vector, and the define goes into the C file, the define all the functions. So again, pretty much I'm just listing here like, hey, declare the type of the struct that I'm going to be using in a second, and then declare all the member methods. Then here, I define all the member methods in this macro. So these macros are actually invoking other macros, which is completely legal. So over here, here's something new. This is going to be the type of our vector, and so we're going to use this vector to get the type of our vector. Because vectors have to have, or I should say, types in C have to have unique names, right? What I'm going to do is I'm going to take whatever the type the user has given me, and I'm going to stick that type in front of the word vector. So back here, since we had like int, it's going to be int vector. And if you look over here in main, I have an int vector. If I had put char there, I'd say char vector or double vector or whatever its type is will show up. I guess that does preclude certain types from not working. For example, if you had like char star, that'd try to make its name as char star, and so it wouldn't work. So some workarounds would probably need to be able to done to handle pointers in our vectors. They don't quite work. But the new thing here is this pound. Pound inside of a macro, only show up inside of a macro, means to concatenate the thing on the left with the thing on the right. So take type, concatenate it together with vector. So if type was int, this expression over here on the right-hand side is int vector. So it literally just glues the two things on the left and the right together. Does that make sense? So this allows me to form that new symbol int vector. Any questions before I keep going? So what does a vector have inside of it? Contents and a length, right? Like we've been working with. So over here, I define a new macro called underscore vector struct declare, and then some type. And so again, whenever this macro is going to be invoked, it's going to be replaced with this body over here, which says type def struct type vector struct, right? So it'll be like int vector struct, char vector struct, double vector struct. Then the contents, right, will be of whatever type star is, a pointer to that type. So if they pass an int, type will be int. If they pass in char, type will be char. And then we have our integer length. Then we close it up, and then here's the ending for my type declaration, right? It's going to be something like int vector or char vector or double vector. Any questions before I go past this point? So what would I get if I called this macro and I passed in the word char here? What would be written by the compiler? Right, we get type def struct char vector struct curly bracket char pointer contents int len, and then our vector type would evaluate to be char vector. Right, so this allows you to kind of like, abstract or generalize creating a vector of any given type. But any questions before I go past here? Yes. The pounds are concatenation. So take the thing on the left, combine it with the thing on the right into one single symbol. So if this is like int and then this is vector, you get, like you have back here, int vector. Any other questions? So these functions over here are just to help me form my name. There's some issues with the concatenation happening correctly. So this function right here just takes a prefix and a function name. Then it calls this helper function down here to actually like stick the two together. So it's going to form the name of the function with the prefix. So over here we have the vector function. So we have vector create length type. This is so that we can refer to these functions inside of our bodies. So over here, this is going to be replaced with vector function name type vector create length. So again, if type was int, vector create length int would get you int vector create length. Right? Or if it was char, you'd get char vector create length. Does that make sense? Because again, the vector function name is going to take this guy right here, this type, and stick it onto the front of this name. So if you have int vector, char vector create length, string vector create length. Does that make sense? And then we basically do the exact same thing for everybody. We just put their name over here on the right-hand side. And then here we have all of our declarations. So I have declare vector create length of some type. And again, our return type of vector create length should be, some vector of this type, right? If it's int vector, if it's char vector. And then underscore vector create length, which again, it's going to be something like int vector create length, char vector create length, double vector create length, right? That's the type that we want to create. And then length takes in one parameter of the length. Any questions here? And then again, this kind of like continues down for some of them. Like maybe a more interesting one might be something like insert, right? So insert returns void. The name of our function is vector insert, again, of this particular type. And then we're going to accept as an argument whatever our vector type is, a pointer to it, so like an int vector pointer, char vector pointer. Then we're going to set a type that we want to insert, and then a position that we want to do the insertion at. Any questions here? So now we have our define. So here's like something like define vector create length. So I use the underscore declare vector length to get the type because the declarations and the definitions have that same first part, like the return type and the arguments. Then I follow it up with a curly bracket. Then I create a new vector of my specified type called vector. I calloc space for its contents, set its length equal to length, and then I return vector. And notice again, like these are all on the compiler to one logical line because these slashes here at the end say continue the line, continue the line, continue the line. Any questions here? So most of the functions you're going to see are like exactly the same thing, except, we have to have all this like nasty extra type stuff in there to make it generate one of the appropriate name. So like here's one where we create a vector of with just a length and a value. So again, declare vector create length. This is going to say something like we're going to return something of vector type, right? And we take in a length and a value of some type. So here we do underscore vector type vector. Well, we call our vector create length function up here, right, of whatever type, and then we make it that long. And then we go in and we fill in the contents. And then we get back to vector. Value, you're going to have to pop back up here. So if we look at declare vector create length, notice the return type is vector type, right? Vector create length value, int length, type pause. So down here, I'm going to actually, invoke this macro in the define. And the define, right, is going to, when you call the declare function over here, the declare macro here, it's going to copy and paste it in. So let's say type was integer. You're going to get the vector type, so int vector create length, right? Then you'll have int length, then int value. So remember pound define is not the same thing as a function definition, right? Pound define is how you create a macro. But down over here, right, in the define vector create length, notice I use declare vector create length, so I get that return type as well as the arguments. And then I just stick on the body. Make it do what I need to do, right? What does this line substitute in? Come back here. So remember, like when we call vector declare create length, it's the same thing as copying and pasting this in right here. I gotta throw an extra slash here at the end to make it stop yelling at me. But notice that when I use that vector declare, it's copying and pasting this in. So hey, look, there's value. Right? Because again, when you call macro, what does it do? Copies and pastes the body. Okay, great. I copied and pasted the body there. Right? So you're going to get, as a return type, it's going to be vector of some type. The function name is vector create length value. Then we're going to accept as arguments length and value. And we're able to work with them. Mean this?
Yeah.
Mean like when I call this function, how do I pass it in? Is that your question? My question is it with this being here as it is, or with it back being to the declare? Either way?
Yeah, I just think how would be
Like right here? Where I invoke my function, I want 5/17s. Okay. So like this is, I'm not going to say necessarily a good use of macros, but it's a slightly more complex use of macros, and it's something that we could only accomplish with them in C, right? We could not do this with a function very easily. We could have something similar if we used void pointers. Void pointers are pointers to something, and if you have me for ECS 50, we'll talk about them then. But Friday, we've pretty much covered C, unless there's anything else you guys want to continue talking about. But we'll get into like Google test and then CMake for like Friday and Monday, and then we might use the last 2 days for review and questions, or I guess last day, because Wednesday's the last day of class next week. We don't have class Friday. Thursday's the last day of instruction next week, and then Friday is the first day of finals. So I will see you guys next week.